August 8, 1944. The Norman countryside near Villers-Bocage lay shrouded in morning mist, the air thick with the acrid smell of cordite and burning diesel fuel. Hauptmann Klaus Weber adjusted his periscope inside his Panzer IV Panther, scanning the hedgerow-lined fields ahead. The massive 75mm KBK 42 L-70 gun of his 45-ton machine dominated the landscape before him, its barrel pointing toward a cluster of American Sherman tanks positioned 300 meters distant. Weber allowed himself a thin smile. More of the Americans' pathetic Ronsons, those gasoline-fueled coffins that ignited at the first penetrating hit. His crew had already claimed 7 of the inferior machines in the past week. This would be another routine slaughter. The Panther's thick frontal armor, 100 millimeters of hardened steel sloped at 55 degrees, had proven impervious to every American anti-tank gun encountered thus far. Weber's confidence was not misplaced arrogance, but calculated certainty born from battlefield experience. The Sherman's standard 75mm M3 L40 gun could barely scratch his tank's armor at this range. He had witnessed dozens of American rounds bounce harmlessly off Panther hulls, while his own high-velocity shells punched through Sherman armor like paper. The mathematical superiority was undeniable. His gun could penetrate 149 millimeters of armor at 1,000 meters, while the American 75mm struggled to pierce 68 millimeters at the same distance. Weber ordered his gunner to acquire the lead Sherman. Through his optics, he could make out the enemy tank's distinctive silhouette. But something seemed different about this particular machine. The barrel appeared longer, more menacing than the stubby guns he had grown accustomed to destroying. Before he could process this observation fully, the world exploded in fire and thunder. The Sherman had fired first, its muzzle flash brilliant even in the growing daylight. Weber felt his Panther shudder violently, heard the distinctive crack of armor being penetrated, smelled the sudden rush of superheated air that preceded death. In that instant, as flames began to lick at the interior of his supposedly impregnable fortress, Hauptmann Klaus Weber became one of the first German tank commanders to experience the lethal reality of the Sherman Firefly, the toy tank that would rewrite the mathematics of armored warfare and shattered German assumptions about American industrial capability. For 3 years, German panzer crews had dominated battlefields across Europe and North Africa with technological superiority that seemed unassailable. The Tiger Y, with its massive 88mm gun and 100mm frontal armor, had become a legend of invincibility. The Panther, introduced in 1943, promised to maintain this supremacy with advanced engineering that combined firepower, protection, and mobility in unprecedented proportions. German tank doctrine, forged in the crucible of blitzkrieg victories, rested on the fundamental belief that superior engineering and battlefield experience would always triumph over mere numbers. American armor had been dismissed with contempt that bordered on professional arrogance. German intelligence reports from 1942 and 1943 consistently characterized the M4 Sherman as mechanically unreliable, insufficiently armored, and armed with a gun suitable only for infantry support. The nickname Ronson, after the cigarette lighter company's advertising slogan, "Lights up first time, every time," reflected genuine German observation of Sherman vulnerability to Panzerfaust attacks and high-velocity anti-tank guns. Statistics supported this contempt. In Tunisia, a single Tiger I commanded by Hauptsturmführer Michael Wittmann had destroyed 14 Shermans in a single engagement without taking a penetrating hit. The mathematical disparity seemed insurmountable. The standard M4 Sherman weighed 32 tons compared to the Panther's 45 tons. Its 75mm M3 gun generated a muzzle velocity of 619 meters per second, while the Panther's KWK 42 achieved 935 meters per second. German armor metallurgy, refined through years of combat experience, produced steel that was both harder and more resilient than early American attempts. The sloped armor design pioneered by German engineers maximized protective value while minimizing weight penalties. By every metric that mattered in tank versus tank combat, American armor appeared hopelessly outclassed. This technological gap had created a psychological fortress around German armored units that proved as protective as their steel plating. Panzer crews entered battle with confidence born from repeated victory against numerically superior but technically inferior opponents. The sight of Sherman tanks advancing across European fields had become a welcome development for German gunners, promising easy targets and quick kills. Combat reports from Normandy's early battles reinforced this perception. German armor consistently achieved kill ratios exceeding 4-to-1 against American tanks, with many engagements approaching complete one-sided massacres. Yet even as German commanders celebrated their technical superiority, British and American engineers were quietly solving the Sherman's fundamental weakness. The solution would not come from revolutionary new tank designs or massive increases in armor thickness, but from a relatively simple modification that would transform the Sherman from prey into predator. The British 17-pounder anti-tank gun, originally designed for towed deployment, possessed the ballistic performance necessary to defeat German heavy armor at combat ranges. The challenge lay in mounting this powerful weapon in the Sherman's relatively compact turret while maintaining the tank's mechanical reliability and operational flexibility. The 17-pounder fired a 17-pound projectile at a muzzle velocity exceeding 880 meters per second, generating kinetic energy sufficient to penetrate 140 millimeters of armor a 1,000 meters. Performance that placed it in the same category as German heavy tank guns. The armor-piercing, discarding sabot rounds developed for this weapon could punch through 208 millimeters of armor under optimal conditions, making even the Tiger I's frontal protection vulnerable. More importantly, the 17-pounders' superior ballistics provided accuracy and penetration capabilities that German crews had never encountered in American armor. Converting the Sherman to mount the 17-pounder required extensive modifications that demonstrated American industrial adaptability. The turret had to be enlarged and reinforced to accommodate the longer gun and its substantial recoil forces. The turret ring required strengthening, ammunition storage needed redesign, and the entire fire control system demanded recalibration. British factories, working in cooperation with American production facilities, began delivering these modified tanks in early 1944, with initial deployments timed to coincide with the Normandy invasion. The Sherman Firefly retained all the operational advantages that had made the basic M4 series successful while adding the firepower necessary to engage German heavy armor on equal terms. Its mechanical reliability remained superior to German tanks, which suffered from over-engineering and component complexity that created maintenance nightmares under field conditions. The Firefly's fuel efficiency allowed extended operations without the constant resupply requirements that plagued German armor. Most importantly, American industrial capacity could produce Fireflies in quantities that German heavy tank production could never match. German intelligence services failed to detect the Firefly's development and deployment, a blindness that would prove catastrophic for panzer crews expecting to face the familiar inadequacy of standard Shermans. The first combat encounters occurred during the initial days of Operation Overlord, when British and Canadian armored units equipped with Fireflies engaged German defensive positions around Caen. German after-action reports from these engagements reflected confusion and disbelief rather than tactical analysis. Tank commanders reported Sherman tanks destroying Panthers and Tigers at ranges previously considered safe. But higher headquarters dismissed these accounts as combat stress or misidentification of enemy vehicles. Obergefreiter Heinrich Müller, a Panther driver in the 12th SS Panzer Division, recorded his first encounter with a Firefly in a letter to his family, dated June 15, 1944. "We positioned ourselves in ambush behind the stone wall, as we have done so many times before. 3 Shermans approached through the orchard, and Hauptmann Schneider ordered us to wait until they closed to 200 meters for certain kills. The lead tank fired before we could engage, and Schneider's voice cut off in mid-sentence. The shell came through our frontal armor like it was tin plate. I have never seen American guns do such damage. Something has changed about their tanks, but no one will tell us what." The psychological impact of these early encounters reverberated through German armored units with devastating effect. Panzer crews who had grown accustomed to engaging American tanks with impunity now faced opponents capable of destroying them at maximum engagement ranges. The comfortable certainty of technological superiority evaporated as reports accumulated of Panthers and Tigers burning after single hits from supposedly inferior American weapons. German tactical doctrine, based on the assumption of armor invulnerability at medium ranges, required immediate and fundamental revision. Combat statistics from July and August 1944 documented the Firefly's transformative impact on armored warfare in Western Europe. British and Canadian units reported kill ratios approaching parity with German heavy tanks, a dramatic improvement from the 4-to-1 disadvantage experienced with standard Shermans. The 17-pounder's superior ballistics allowed Firefly crews to engage German armor at ranges exceeding 200 meters while maintaining high probability of penetration. German tanks, previously capable of destroying multiple Shermans before receiving return fire, now faced immediate retaliation from weapons capable of matching their own firepower. The Battle of Villers-Bocage on June 13, 1944, illustrated the Firefly's potential impact when properly employed. Michael Wittmann, Germany's most celebrated tankist, with 138 confirmed kills, led a force of Tigers and Panzerabwehren against British armored units advancing toward Caen. Wittmann's initial assault destroyed multiple British vehicles, but his Tiger I was subsequently knocked out by a Sherman Firefly commanded by Sergeant Gordon. The loss of Wittmann, later determined to have been killed by either Firefly or anti-tank gunfire, sent shockwaves through German armored command and demonstrated that even the most experienced crews were vulnerable to improved Allied weaponry. German attempts to counter the Firefly threat revealed the limitations of their industrial capacity and strategic position. The Panther's armor was already at the practical limits of German metallurgical capability and tank mobility requirements. Increasing armor thickness would have reduced mechanical reliability and tactical flexibility while consuming scarce materials needed for other military production. The Tiger II, introduced in late 1944, represented the ultimate expression of German heavy tank philosophy, but its massive weight and complexity limited production to small numbers that could never match Allied tank output. More significantly, German fuel shortages increasingly restricted armored operations regardless of technical specifications. The Panther consumed 2.3 liters of fuel per kilometer under combat conditions, compared to the Sherman's 1.4 liters per kilometer. As Allied bombing devastated German synthetic fuel production and captured territory-reduced access to Romanian oil fields, German tanks became immobilized fortifications rather than mobile weapons. The Firefly's superior fuel efficiency, combined with American logistical capabilities, provided operational advantages that no amount of armor thickness could overcome. American tank crews initially approached the Firefly with skepticism born from months of engaging German armor with inadequate weapons. Staff Sergeant Robert Thompson, a Firefly commander in the 1st Armored Division, recalled his unit's first encounter with Panther tanks near Metz in September 1944. "We'd been getting knocked out at long range for so long that seeing Panthers 1,200 meters away meant immediate withdrawal. But Lieutenant Morrison ordered us to engage, and I put a sabot round through the lead Panther's turret face at maximum range. The crew bailed out before the smoke cleared. We couldn't believe we'd finally gotten a gun that could reach out and touch these bastards. The transformation of American armored confidence paralleled the deterioration of German morale as Firefly encounters became routine rather than exceptional. Tank crews who had endured months of technological disadvantage now possessed weapons capable of engaging any German vehicle on equal terms. The psychological impact of technical parity proved as significant as the tactical advantages, allowing American armor to operate with aggressive confidence rather than defensive caution. Combat effectiveness improved measurably as crews learned to exploit the Firefly's capabilities against opponents who had lost their aura of invincibility. German training manuals from late 1944 reflect the doctrinal confusion created by Allied technical improvements. Previous instructions emphasized close engagement with American armor to ensure penetration while remaining outside the effective range of Sherman guns. Firefly deployment made these tactics suicidal, but German armor schools struggled to develop alternatives given their strategic situation. New guidance recommended maximum engagement ranges and emphasized target identification to distinguish standard Shermans from Firefly variants, but combat conditions rarely provided the time or visibility necessary for such discrimination. The Battle of the Bulge represented Germany's final attempt to achieve decisive victory through armored superiority, but even this massive concentration of remaining panzer forces could not overcome the cumulative impact of Allied technical improvements. German armor achieved initial tactical success through surprise and concentrated force, but sustained operations revealed the fundamental weakness of their strategic position. Fuel shortages immobilized entire armored units within days of the offensive's launch, while Allied air power and artillery destroyed German supply columns attempting to maintain the advance. Firefly units played crucial roles in containing German breakthrough attempts during the Ardennes offensive. The 17-pounder's effectiveness against German heavy armor proved decisive in several engagements where numerically inferior Allied forces halted German advances through superior firepower rather than tactical maneuvering. Combat reports from Bastogne and Saint-Vith documented multiple instances of single Firefly tanks destroying German armor columns by engaging lead vehicles at maximum range, creating roadblocks that prevented further advance while calling in artillery. Strikes against immobilized formations. 3D symbolic power of the Firefly extended beyond its technical specifications. TOR present broader themes of Allied industrial adaptation and democratic resilience. Unlike German superweapons that consumed enormous resources while delivering minimal battlefield impact, the Firefly demonstrated how incremental improvements to existing designs could achieve revolutionary results through intelligent engineering and efficient production. The marriage of British ballistic expertise with American manufacturing capacity exemplified the Allied technical cooperation that ultimately overwhelmed Axis industrial capabilities. Production statistics illuminated the mathematical inevitability of Allied victory once technical parity was achieved. German industry produced approximately 6,000 Panther tanks between 1943 and 1945, representing the pinnacle of their armored vehicle development. American factories manufactured over 49,000 Sherman tanks during the same period, with nearly 2,100 converted to Firefly configuration by British modification programs. The numerical disparity meant that even superior German crews and vehicles could not achieve kill ratios sufficient to prevent eventual defeat through attrition. German tank crews adapted to Firefly threats through tactical modifications that revealed their declining strategic position. Engagement ranges increased dramatically as crews sought to minimize exposure time while maximizing their own weapons' effectiveness. Defensive positions became more elaborate and carefully concealed, but these adaptations reflected weakness rather than strength. German armor, originally designed for offensive operations and breakthrough battles, was increasingly relegated to static defensive missions that negated its mobility, advantages while emphasizing the importance of superior firepower. The capture of intact Firefly tanks provided German intelligence services with detailed technical information about Allied capabilities. But this knowledge came too late to influence German production priorities or tactical doctrine significantly. Examination of the 17-pounder gun and its ammunition revealed ballistic performance that German weapons could match but not exceed given existing industrial constraints. More troubling for German analysts was the Firefly's demonstration that Allied technical competence had reached parity with German engineering while maintaining superior production efficiency and logistical support. Combat veterans from both sides recognized the Firefly's pivotal role in transforming armored warfare during 1944 and 1945. German tank commanders, interviewed after the war, consistently identified Allied technical improvements rather than numerical superiority as the decisive factor in their defeat. The psychological impact of facing opponents capable of destroying German heavy tanks at long range proved as significant as the tactical implications, destroying German confidence in technical superiority that had sustained their forces through years of increasingly desperate fighting. American crews who had experienced both standard Sherman combat and Firefly operations provided detailed comparisons that highlighted the transformation in tactical capabilities and psychological confidence. The ability to engage German heavy armor on equal terms fundamentally altered combat dynamics, allowing American forces to operate with aggressive confidence rather than defensive caution. This change in battlefield psychology proved as important as the technical improvements themselves, enabling more effective tactical employment of Allied armored forces during the final campaigns of the European War. The Fireflies' development timeline revealed the superior adaptability of Allied industrial systems compared to German technical rigidity. From initial concept to battlefield deployment required less than 2 years, with production modifications implemented while maintaining full-scale manufacturing of standard Sherman variants. German attempts to develop comparable improvements to their existing armor proceeded more slowly and consumed resources that could have been devoted to increasing production of proven designs. The bureaucratic complexity of Nazi administration created delays and inefficiencies that prevented rapid response to changing battlefield requirements. Technical analysis of Firefly ammunition revealed sophisticated metallurgical advances that demonstrated Allied scientific capabilities. Armor-piercing discarding Sabatrons used tungsten cores and advanced ballistic design principles to maximize penetration while maintaining accuracy at extended ranges. The development of these projectiles required coordination between British research facilities, American manufacturing plants, and Canadian raw material suppliers, illustrating the collaborative advantage that Allied forces possessed over increasingly isolated German industry. The impact of Firefly deployment extended beyond direct tank versus tank combat to influence broader tactical doctrine and operational planning. German forces were compelled to devote increasing resources to anti-tank defense while reducing their capability for offensive operations. The threat of long-range Allied tank guns forced German infantry to operate within smaller defensive perimeters, while calling for artillery support against targets that previously would have been engaged by direct fire weapons. These tactical adjustments consumed ammunition, communication resources, and command attention that further degraded German operational effectiveness. Post-war analysis by military historians consistently identified the Sherman Firefly as zone of the most significant technical developments of the European theater, not because of revolutionary innovation, but through intelligent adaptation of existing capabilities to meet specific battlefield requirements. The success of the Firefly program demonstrated principles of weapons development that would influence post-war military planning. Incremental improvements to proven systems often provided better results than attempts to develop completely new technologies. Under wartime constraints, the contrast between Allied technical adaptation and German superweapon development illustrated fundamental differences in strategic thinking and resource allocation. While German industry pursued projects like the Maus super heavy tank and advanced jet aircraft that consumed enormous resources while delivering minimal battlefield impact, Allied engineers focused on improving existing systems to achieve maximum combat effectiveness with available materials and manufacturing capacity. The Firefly exemplified this pragmatic approach, transforming a supposedly obsolete tank design into one of the war's most effective tank destroyers. German prisoners of war, interrogated during and after the Normandy campaign, provided detailed insights into the psychological impact of facing improved Allied armor. The comfortable certainty of technical superiority that had sustained German morale through years of increasingly desperate fighting evaporated as reports accumulated of Panthers and Tigers burning under Firefly guns. Combat veterans who'd survived engagements against standard Shermans expressed genuine fear when facing Allied armor formations that might include Firefly variants, describing a level of anxiety previously unknown in German armored operations. The logistical implications of Firefly deployment revealed another dimension of Allied strategic advantages. The 17-pounder gun used different ammunition from standard Sherman weapons, requiring modifications to supply chains and ammunition distribution systems. American and British logistical services accomplished these changes while maintaining support for existing weapon systems, demonstrating organizational flexibility that German supply services could not match under increasing pressure from Allied bombing and territorial losses. Combat statistics from the final months of European fighting documented the cumulative impact of Allied technical improvements on German armored effectiveness. Kill ratios that had heavily favored German tanks during 1942 and 1943 approached parity by late 1944, with Firefly-equipped units consistently outperforming standard Allied armor in tank versus tank encounters. The mathematical advantage that had sustained German tactical doctrine disappeared, as Allied forces achieved technical parity while maintaining overwhelming numerical and logistical superiority. The 3D transformation of German tactical doctrine in response to Firefly threats revealed the fundamental weakness of their strategic position. By 1944, armored units originally designed for offensive breakthrough operations were increasingly committed to defensive missions that negated their mobility advantages while emphasizing firepower capabilities, where Allied forces had achieved equality or superiority. German commanders recognized this tactical evolution, but lacked alternatives given their deteriorating strategic situation and limited industrial capacity for developing countermeasures. Individual combat accounts from Firefly crews provided human perspectives on the technical revolution in armored warfare. Tank commanders who had endured months of technological disadvantage described the psychological liberation of finally possessing weapons capable of engaging any German vehicle on equal terms. The confidence boost from technical parity proved as significant as the tactical advantages, enabling more aggressive employment of Allied armor. During the final campaigns of the European War, while reducing casualty rates among experienced crew members whose survival was essential for maintaining unit effectiveness, the Firefly's success influenced post-war tank development programs in both Allied and former Axis nations, establishing principles of weapons design that emphasized firepower and accuracy over maximum armor protection. The demonstration that existing vehicle platforms could be effectively upgraded with improved weapons systems became a standard approach to military modernization, avoiding the massive costs and development delays associated with completely new vehicle designs. The pragmatic engineering philosophy exemplified by the Firefly program continued to influence military planning. Throughout the Cold War period, German technical intelligence reports from captured Firefly vehicles revealed grudging respect for Allied engineering, capabilities that contrasted sharply with earlier dismissive assessments of American industrial competence. Detailed analysis of the 17-pounder gun installation praised the mechanical reliability and maintenance accessibility of the system while acknowledging its superior ballistic performance compared to existing German weapons. These reports reflected the broader German realization that Allied technical capabilities had reached parity with their own while maintaining superior production capacity and logistical support. The symbolic significance of the Sherman Firefly extended beyond military circles to present broader themes of democratic innovation and industrial adaptation. The successful marriage of British ballistic expertise with American manufacturing capability demonstrated the collaborative advantages that Allied forces possessed over increasingly isolated Axis powers. This technical cooperation became a model for post-war military development programs and influenced the creation of NATO standardization agreements that enhanced interoperability between Allied forces. During the Cold War period, as the European War entered its final phase, German tank crews faced the daily reality that their technological superiority had evaporated through Allied innovation rather than overwhelming numbers alone. The sight of Sherman tanks on the battlefield no longer guaranteed easy victories, but promised dangerous encounters with opponents capable of matching German firepower and exceeding German reliability. This transformation in battlefield psychology proved as decisive as the technical improvements themselves, destroying the confidence that had sustained German armored forces through years of increasingly desperate fighting against superior numbers. The mathematics of attrition warfare became inescapable once Allied forces achieved technical parity with German armor. Superior American industrial capacity could replace losses at rates that German production could never match, while improved Allied weapons reduced the kill ratios that had previously offset numerical disadvantages. The Firefly represented the culmination of this process, providing Allied forces with weapons capable of defeating the best German armor while maintaining their reliability and producibility that characterized American military equipment throughout the conflict. In the final analysis, the Sherman Firefly's impact transcended its immediate tactical significance to embody larger truths about the nature of democratic warfare and industrial adaptation. The transformation of a supposedly obsolete tank design into one of the war's most effective tank destroyers demonstrated the innovative capacity of free societies under pressure, the power of international cooperation in technical development, and the ultimate futility of authoritarian reliance on superweapons rather than systematic improvement of existing capabilities. The German crews who had mocked America's toy tanks learned too late that democratic ingenuity, combined with industrial abundance, could transform any weapon into an instrument of victory. The thunder of that first Firefly gun, echoing across the Norman countryside on that August morning in 1944, announced more than the destruction of another Panther tank. It proclaimed the end of German technological supremacy, the triumph of Allied industrial cooperation, and the inexorable mathematics of a war where numbers backed by innovation would always overcome individual excellence unsupported by adequate resources. Hauptmann Klaus Weber's final moment of recognition, as 17-pounder shells pierced his supposedly invulnerable armor, marked not just the death of a tank crew, but the death of an illusion that had sustained German resistance long past. The point of rational hope, the Sherman Firefly, stands as testament to a fundamental truth about the nature of technological warfare, that superior engineering means nothing without the industrial capacity to produce weapons in decisive quantities, and that the marriage of technical competence with democratic values creates innovations that authoritarian systems, for all their theoretical efficiency, can never match. In the end, it was not the complexity of German superweapons, but the elegant simplicity of Allied adaptation that wrote the final chapter of armored warfare in Europe, proving that democracy's greatest weapon was not any single invention, but the collective ingenuity of free peoples united in common cause against tyranny.